In this video, I show you how to make this glass breaking effect in Blender. At the end, we will add a bit of speed ramping as well. So let's get started. I start by setting the scene frame rate to 60 FPS. Add a cube and scale it up like this to act as our floor. Apply the scale with Ctrl A and rename this to ground. I add another cube. Bring it up. Scale it down along the x-axis. I set this to 0.01. Apply the scale. This is our glass layer. I move it to the side. We can change the viewport shading color to random to better see the individual objects. Then I add a sphere. Scale it down a bit and place it behind our glass. Add a keyframe for its location. Go a few frames forward. Place it in front of the glass and add another keyframe. On the timeline, I select both keyframes and hit T to bring up the interpolation menu. I set the interpolation to linear. This way, there will be no ease in or ease out in the animation. I call this ball. This ball is going to break our glass. To break our glass into pieces, first go to Edit, Preferences and make sure the Cell Fracture add-on is enabled. I believe it is enabled by default. If not, check this box to enable it. To access the add-on, go to Objects, Quick Effects and Cell Fracture. It will bring up this menu and here we can tell Blender how we want to break the glass object. I am going to use this annotation grease pencil method. But before that, I need to draw the breaking pattern. So click away. I go to this side view. The ball is hitting right in the middle of the glass. I keep that in mind and hide the ball from the viewport. Then switch to this annotation tool. Change the placement to surface. This allows us to draw on the surface of objects. I changed the color to red so you guys can see it clearly. Now I just draw these spirals around the area where the ball hits the glass. I try to mimic the break-in pattern of glasses. These lines will not be the cracking lines. Cracks will happen in between these lines. I draw some dots to get more pieces close to the edge of the glass. So I drew something like this. Now to break our glass into pieces using these grease pencil lines, select the glass object, go to Object, Quick Effects, Cell Fracture. You don't need to get intimidated by this huge menu. We're only going to use a few of these options. First, I set the breaking method to annotation pencil. Source limit determines how many pieces we want this to break into. I set that to 400. Also, I reduce this margin by 10 times. It will reduce the gap between pieces. Here I have the option to put the pieces into a new collection. You can either type the exact name of an existing collection or type a new name to create a new collection from that name. Here I will put these pieces into a new collection named Glass Pieces. Also, I disable this Show Progression checkbox. Then hit OK. Just like that, it broke the glass into a bunch of pieces and put them into a new collection. We have 399 pieces. I hide the original glass object. To hide the annotation lines, I bring up this panel and go to View, Annotations, and here I can remove or hide the annotation lines. You can see around the area where we drew a bunch of small spirals, we have small pieces. I select all the pieces and go to edit mode. Make sure all the pieces are selected and hit M and merge by distance. This will remove any double vertices. Also, it is better if you set this merge distance value to less than what we set for the pieces in the cell fracture menu. This will optimize our pieces for the rigid body sim. Now our pieces are ready for a rigid body simulation. To add rigid body to glass pieces, select all the pieces and go to Object, Rigid Body and Add Active. Now when you hit play, all the pieces are falling due to gravity. In fact, they are falling through the ground. To prevent that, select the ground object, go to Object, Rigid Body and Add Passive. You can do the same by going to Physics tab and adding the rigid body from here. Pick the active or passive type from this menu. Here I changed the collision shape to box. Now you can see pieces are colliding with the ground. Although these pieces are in different sizes, they are all share the same mass. That doesn't make sense. So to change that, select all the pieces. Make sure you have one active object in that selection, one with a yellow outline. Then go to Object, Rigid Body, Calculate Mass. Here this gives me a list of options and I select glass broken. This will add different mass to each piece based on their volume. Now when it hits the surface, it breaks in a more realistic way. Also, I select the ground object and increase its friction value. It will reduce the sliding. I set the frame range to 120. Right now, they start falling immediately. I want them to stay where they are until our ball hits it. So I select one piece and in dynamics I enable both deactivation and start deactivated. This will make sure until this amount of force applies to the piece, the simulation will not start. It is not working. I need to make that change to all the pieces. So I select all. Make sure our previous piece is the active object. Then go to Object, Rigid Body, Copy from Active. This will copy all the settings from the active object to the rest of the selection, which means it's also copied that mass as well. So I calculate the mass again. Now you can see it is not falling immediately. Let's make our ball hit these pieces. I select the ball object and add a rigid body to it. And you can see now it is not animating and just falling down. To make the animation work with the rigid body, you have to enable this animated option. And now you can see it is hitting our glass pieces and kick-starting the simulation. Now after it breaks the glass, I animated this checkbox to disable that animated option. This way, after that frame, rigid body physics will drive the ball's movement. I increase the ground scale. Apply it. Now, since I am hoping to mimic a glass window, I don't want all the pieces to fall off. Some pieces can stuck to the window frame. So, to mimic that, I hit C to get the Circle Select tool and select these corner pieces. You can use the middle mouse button to deselect objects. Use the scroll wheel to increase or decrease the selection radius. Then I go to Object, Rigid Body, Add Passive. This will change the rigid body type of those pieces to passive. Now you can see those pieces sticking to their corners. I change some pieces back to active. Then I select some pieces around the center point. Select one in the center to make it the active object. Then go to Object, Rigid Body, Connect. This will create a bunch of empties with rigid body constraints on it. They will link each selected piece to the active object. Here I select all of these constraints and put them into a new collection. To break the link after some time, I enable this breakable option and decrease the threshold value. Hold Alt key while enabling it to make that change apply to all constraints. Or you can select all constraints object and in the active object, hover over the value you want to copy and right click and select Copy to Selected. That also copies that value to all the selected objects. Here I try to play with the threshold value to get this work smoothly. It worked nicely in my test before, but here I failed to get it to work. Probably I am doing something wrong, but couldn't able to figure out exactly what it is. So after a little while I gave up on that and deleted all the constraints. But I recommend you guys to play with it. It will add more realism to your breaking pieces. So we have big glass pieces, small pieces. Let's add some tiny glass pieces as well. I select these pieces. They will going to emit tiny glass pieces when breaking. I duplicate the pieces and hit M to move them to a new collection. Hide the original pieces collection. Select all the duplicated pieces and duplicate them one more time. And hit Ctrl J to join them into a one object. Move it out of the collection. Hide that duplicated pieces collection. I need them later. I want to emit tiny glass particles from the side faces of these pieces. You can just emit them from this current shape, but I think it would be a bit more realistic if the tiny particles emit from the space between bigger pieces. I rename this to glass particles and go to Edit mode. Side view. Make sure face selection is enabled. Move to wireframe view. Select all these faces on the side profile. You can use either circle select or box select to select them faster. Then hit Ctrl I to inverse the selection and X to delete all those faces. That leaves me with these faces. Back in the edit mode, select all these faces, change the pivot point to individual origins and scale them down a bit. This will increase the space between each piece. I remove this rigid body and create a new particle system. Our ball is hitting the glass at frame 13. So I select the start and end value to 30. This will make all the particles present in that frame. I reduce the particle count to 500. Increase the lifetime to make sure they last the entire animation. In the physics tab, I set the physics to none for now. And here in the viewport display, I reduce the particle size to see all of them clearly. In the source settings, I change the distribution to random. I go back to edit mode and subdivide the faces. It will add a bit more randomness to the particle distribution. I set the physics back to Newtonian. Disable the show emitter. To interact these particles with our ball, I add collision to ball physics. Now you can see particles are pushing forward by the ball, but they are falling through the ground. So select the ground and add collision to it. Now they are colliding with the ground and bouncing too much actually. So I select the ground object and add some stiffness to it. Increase the damping and friction as well. Add some randomness. To reduce particles clumping with each other, I add some velocity to them. Right now, they are falling faster than bigger chunks. So, I add a bit more velocity to push forward. Reduce the mass. More importantly, I reduce the gravity, which is going to have the biggest effect on the particles. I settle with 0.25. Now to change these particles to glass pieces, in the render section, I change this to collection and select our glass particles collection. Adjust the scale and add some randomness to them. Also check this pick random box. This will pick a random object from that collection for each particle instead of picking the whole thing. Adjust the scale necessarily. Once you get the simulation right, here in the cache, I enable this cache. Give it a name and bake the simulation. Now I select all the glass pieces and the ball. Go to Object, Rigid Body and Bake to Keyframes. Set the frame range as you want and hit OK. It might take some time depending on your PC. Once it is done, you will see it baked all the active rigid body's movements into keyframes. If you want to make a slow motion glass breaking, you can select these keyframes and scale them like this. But it is probably not the best way if you have other things going on in the scene. So I will slow this down a bit later with a different method. Let's render this thing out. I add a camera. Place it like this. Change the focal length to 35mm. I adjust the camera angle to capture the breaking from here. Now I make a few more windows in the workspace. Just drag from the corners. Make sure your camera is not in our glass collection. You don't need to worry about it if you click on the other collection icon. That way, that collection becomes the active collection and every new object you add to the scene will go inside it. In the camera settings, I change this value to 1. This will darken the surrounding of the camera view, giving us a better view. Change this window to shader editor. Go to render view with the first window. Select the ground object and create a new material. Make it darker and reduce the roughness a bit. Select the ball, create a new material. Make it metallic and adjust the roughness a bit. I darken its color as well. Then I select one of these glass pieces. Create a new material and call it glass. Set the color to full white. reduce the roughness to almost 0. Here in the transmission, increase the weight to 1. To add this material to all glass pieces, I right-click on the collection, select Objects. Then in the Active Objects Material tab, click this arrow and copy material to selected. This will add that glass material to all the glass pieces. And to add this to tiny glass particles, I unhide the glass particles collection and add glass material to them as well. Also, don't forget to add the glass material to our original glass object. It will be visible to the camera until the ball hits it. Here for some reason my material shows black. Maybe because this is my second time doing this phase of the tutorial. I forgot to screen record the first attempt. Anyway, I restart Blender and open the project again and it fixed the issue. Okay, now let's light this scene. I add a sun lamp and rotate it like this to light the glass pieces from the back. Also increases its strength. I darken the ground material a bit more. Then add an area lamp and put it above the glass. Increase the lamp size and strength. Then to deal with our world, I switch from object shading to world shading. Select this background node and hit Ctrl T to bring these 3 nodes. I don't need the environment texture. Instead, I plug a gradient texture. Then plug window coordinates to here. What this does is, it maps the texture to the window we are looking at. You can see here when I change the size of the window, the texture stretches according to it. So whenever you use these window coordinates, make sure to do all the adjustments looking from the camera view. Otherwise, you will get slightly different results when rendering. I change the gradient type to spherical. Change this X location to -0.5 to center it. Then add a color ramp to here and change it to use B-spline. This way I can get smoother results. Adjust the sliders and their values to get a nice gradient. I darken the ground material a bit more again. Now it is time to change the visibility settings to make the original glass break. I hide the glass pieces. Unhide the original glass object. I go to the frame where the ball is just about to hit, and here create a keyframe for both render visibility and viewport visibility. Go to the next frame, disable both of them and hit I to add a keyframe. Now you can see it hides itself when the ball hits the glass. I do a similar thing to glass particles as well. In reverse actually. I disable it until the ball hits the glass and enable it after hitting the glass. Now you can see particles are only visible after frame 13. It would have been so much easier if we could do the same thing to our glass pieces. But unfortunately we can't keyframe collection visibility. So either you have to add those keyframes to each pieces or use collection instance to do it. Since I believe a lot of you are not familiar with collection instances, let's do it that way so you can also learn something new. Hit Shift A and get the Add menu. At the bottom under Collection Instances, you will see all the collections you have in the project. Select our glass pieces from here. Now if I hide the original glass pieces collection, you can see we have a clone of it, an instance, and it has our bake simulation as well. But one issue with this is in order to render collection instances, you need to have the original collection set to render as well, which means you can't disable it from the render. And because of it, these two are currently overlapping. So to prevent the original collection and the instance from overlapping, I am going to move the original collection out of the camera view. Since we have a few hundred objects in there and they also have baked keyframes, I add an empty to change their position at once. You can keep it inside that collection, but I move it out. Then select every object in that glass pieces collection. Shift select the empty. Ctrl P to parent it. Use keep transform. Now you can see every single piece is attached to that empty. I select the empty, hit G, Z and type -5 to move it 5 units down, which means our instance did the same as well. So I select the instance and move it 5 units up to bring it to its original location. Now you can see we have our original collection below the ground, not visible to the camera, and the instance is above the ground where the original glass pieces collection was. Now, like before, I can make keyframes for instance visibility to make it only appear when the ball hits the glass. And just like that, we have our glass breaking animation. In the camera, I enable depth of field and select our original glass object as the focus point. Let me also add a second camera to the scene. But before that, I bind the current camera to the timeline. Select the camera and hit Ctrl B on the timeline. Then go to the frame where you want to switch the camera and duplicate the camera object. Back in the timeline, hit Ctrl B to bind that second camera to the timeline. Now I adjust my view like this and hit Ctrl Alt 0 to align the camera to that view. Adjust the camera location and orientation to get a better view. And that is our glass breaking effect in Blender. To add a bit more slow motion to the simulation, I will use Davinchi Resolve. Let me show you that process with a viewport render of the scene. Here in the render output settings, I pick a path to store the rendered images. And since I am doing a viewport render, I set the format to JPEG. But for final renders, I recommend using OpenEXR format. Then in this window, I go to View and Viewport Render Animation. This will render out the viewport into an image sequence. Now in Davinchi Resolve, in the media page, I locate the rendered frames. If you do not see this as a sequence, click on these 3 dots and set the frame display mode to sequence. Now drag this to the media pool. In the edit page, if I check the clip attributes, you can see it imported as a 24 FPS footage, which is fine. Now drag the clip to here to create a timeline from it. In Blender, we worked at 60 FPS, making the scene last only 2 seconds. Here, since it is set to 24 FPS, it lasts 5 seconds, 2.5 times slower. But I want to speed ramp it. I right click on the clip and enable retime curve. Pick where I want to speed ramp and click this to add a keyframe. I add another one here as well. Now to speed up the beginning of the clip, drag from here and move it up until it hits 250, which is equivalent to 60 FPS speed we had in Blender. Do the same for here as well. You can see since the clip's speed is going up, that part of the clip is becoming shorter as well. I adjust the position of the keyframes a bit. Also, select the keys and click on this icon to smooth the speed change. You can adjust the handles and the key position to get a smooth speed ramping effect. Once you render the footage in Blender, you can do these steps inside Davinchi Resolve to get that smooth speed ramping effect. Huge thanks to this amazing individual for making these videos possible. And as usual, all the project files are available for Patreon members. See you in the next one.